So that's our supplement update. We can probably address that subject again since not everyone's here, and it's a vast subject. We can talk about it from different angles. Next time I might show you some of the anatomy about how B12 gets absorbed. If we didn't have that absorption mechanism, then the small amounts that the bacteria make and contaminate our food on the skins of our potatoes and so on, there's bacteria. And if we don't scrub them well, we're getting B12, but in such small amounts. So it's wonderful that our Creator made us with an absorption that can pull in actively these very small amounts. If it didn't have this absorption using those cofactors, the intrinsic factor, then the bacteria would really have to turn out high levels of B12 for us to just get it through passive absorption into our small bowel. So I want to turn to the handout called alkylphenol. So today's lecture would be on understanding this chemical, what it does to us, and then if we have time, we may not. The next one following this is what foods have this chemical in them, so we can avoid those foods that aren't helping us be healthy. So. So this is, again, from nutritionfacts.org, a website by Dr. Michael Greger. And so I'll just play the video, but the handout you have is just a transcript of what he's saying in that video. I think it went to sleep. I'll rewind it. Not sure if it goes to sleep, why it disconnects to Bluetooth.
Is your audio muted?
It was working a second ago. I think it just disconnected Bluetooth when it fell asleep.
Always work better before you actually need them.
All right.
And when you go to actually need them, like you're in front of a class or something else,
Yeah, now
that's when they act up.
all right, now we got it.
And computers must know somehow when you're desperately need them and when you don't desperately need them.
The author recommended multivitamins, which I thought was interesting. Yeah, you know.
Let's see, now that everybody knows it.
Well, it should be accepted.
Was that the audio over there on the left-hand bottom icon?
It's talking now.
There's no cord blood going to our baby. How did it get there? How do people get exposed? Through contaminated food.
That's the secret.
In my video, Preventing Childhood Allergies, I noted a study in Japan that found a higher maternal intake of meat during pregnancy was significantly associated with about 3 times the odds of both suspected and physician-diagnosed eczema. They suggested that certain components of meat may affect the fetal immune system, but what about the moms themselves? Seasonal allergies have exploded in Japan in the past few decades, starting with the first reported case in 1964, now affecting millions every year. We've seen rising prevalence of allergic diseases around the industrialized world in past decades, but perhaps nothing quite this dramatic. Researchers suggest that profound changes in the Japanese diet may have played a role. Over the latter half of the century, total meat, fish, and milk intake rose hundreds of percent in.
Some of these graphs go by, and he knows that it's too fast for you to actually look at and understand. So I slow it down so you can actually take a little time to look at the numbers. So he's talking about allergies, basically. Childhood allergies, adult allergies. And he's focusing on a study done in Japan, where compared to a generation ago, we're seeing much higher levels in the people of Japan with allergies. And so they're trying to sort out, where's this coming from? Is it from something they're eating? Is it from mutations in our genes? Is it from food in our environment or chemicals in our environment? So that's what the research is trying to sort out. What's causing this explosion of allergies? And when you say allergies, it's a bigger topic. It's not just seasonal allergies, but that is one of the big factors. Some people lump in eczema. Eczema is where your body is hyperreactive to some kind of chemical. And that's the simplest way to explain it. And so you can think of it like an allergy, but it doesn't show up as runny eyes and itchy nose. It shows up as little white dots on your skin. They're not like the dots of chicken pox, but you can feel them if you kind of run your hand over them, just like white little raised dots or specks on the skin. And usually it's in places where the skin is thinner, where you will find it.
High meat eating does it, high meat consumption.
So eczema is often diagnosed in children. So that's lumped under this kind of bigger umbrella of allergies. So here, if you look at the time frame on the column 1958, they're showing how much rice people are eating. So it looks like it's close to 600 grams per day of rice that they were eating in 1958. Now in 1999, the people are eating 236 grams. So that's less than half of their calories are now coming from rice. So unless they're getting very skinny and starving, it means they're getting their calories from some other source. And so if you look here, they're back in 1958, they ate 13 grams from meat. Now it's 92. So that's like 6 times higher grams of protein that is coming from meat. And the same with shellfish has increased, but not as dramatically. Fish consumption, shellfish, was 56 grams in 1958, and now it's 71. It looks like in 1989 it was even higher, but they've trimmed that down. I'm guessing, no, this was, I think Fukushima happened after 1999.
Isn't that calorie grams, not protein grams chart?
Well, yeah, they're grams, but most of those grams in animals is from protein. But you're right, fat is a big factor too. They're just saying grams of fish or
Yeah.
servings of fish.
So I'm
Not
thinking that's
some
calories.
is protein, but a third of our meat calories are in fat. You can't get the fat out of the meat.
So it's 2/3 fat.
2/3? Okay. It's a lot. And of course, milk consumption has gone up about 6 times in that interim. So they're getting more calories from milk, fish, shellfish, and meat, and they're eating half as much calories from rice. So then let's see where that takes these people.
To look into dietary meat and fat intake and the prevalence of these seasonal pollen allergies. No association with overall fat, but higher meat intake was associated significantly with an increased prevalence of disease. So maybe it was the saturated fat? No, that didn't seem to be it. So what other constituents in meat may be to blame?
He doesn't talk about what you're saying.
Okay, he does.
The one question was it the extra fat that is in their diet? Because the fat wasn't coming from rice, it was coming from these sources of meat, which fat is a big part of the calories. But they must have found a way to control for that. He doesn't refer to that answer to that question, but it wasn't caused by the fat.
Carcinogens, the heterocyclic amines, polycyclic aromatic hydrocarbons, and nitrosamines, but who knows? This new review, however, raised an intriguing possibility. There's a class of industrial pollutants called alkylphenols, recognized as common toxic endocrine-disrupting chemicals that tend to accumulate in the human body and may be associated with the adverse effects of allergic diseases. A variety of studies have shown how they may exacerbate allergen-induced inflammation, suggesting that alkylphenol exposure may influence the onset, progression, and severity of allergic disease.
So those little, he highlights a sentence, kind of that's the take-home message from each of those studies. So at the bottom of your screen he's saying they're suggesting a connection between this chemical alkylphenol and increased prevalence of these allergic diseases. And so he's going to explain a little bit more about alkylphenol, how we can avoid it.
Xenoestrogens can be found in human breast milk, stored up in our body fat, coursing through our urine, our bloodstream, and even the umbilical cord blood going to a...
So is that, for those who can't see the small print up there, he's finding places in the human body that we can identify this chemical alkylphenol that they believe is in our environment, and it's contributing to these chronic inflammatory diseases like allergies. And so this chemical it's stored in our fat. Whenever you know of a chemical that's stored in your fat, it's sensitive to biological multiplication is a term we use, which means that if an animal eats another animal, and that's how the food chain is, you know, birds eat the insects, a cat eats the bird, let's say the coyote eats a cat. Each of those animals are now storing the alkylphenol in their body, and that fat stores then get transferred into the animal that ate it. And so the alkylphenol then gets stored in the fat of the animal that just ate it. And so it might be in very small amounts at the insect level, but then as it gets concentrated by these different animals eating each other, we call that magnification. And we look at DDT, kind of had the same effect. It got stored in the fat that way.
Oh, yeah.
And its effect, even though it was very small in the environment, it got, as the eagles would eat the fish that ate the other fish that ate the smaller fish, the eagle was getting so much of the DDT that its shells, egg shells, were very weak.
So the alkyphenols can contribute to skin problems like eczema. and
That's
things.
That's what their conclusion is.
Okay, can there be, is there a test to see, like a blood test or something that could see if there's a level of certain amount of that in our system?
Well, I don't know that there is a common test. These are researchers who have this, they usually use these special chromatography equipment where they can take these very minute amounts and actually measure them accurately. That's not something that's usually done to our blood. It's a more expensive to run that researchers will use, but I don't know that it's a commercial test that a doctor can order.
Would it show up on an extensive hormone test scan? Is it hormone or?
I don't think a lot of these toxins are in our standard tests. You'd have to order some very exotic test, maybe send it to a special lab. If you're trying to work up some toxic, let's say
Profiling.
you're trying, the EPA is trying to figure out who's been affected by some toxic exposure. So the mother can give it to the children, and so breast milk has this. Well, then you think, well, that means I shouldn't nurse my kid, right? Well, it turns out the cow's milk has it also. So you actually have 5 times more in the formula made from cow's milk than from breast milk. And so it's in our environment at very low levels. So you think, well, if it's so low level, why should we care about that? Well, it turns out these chemicals have hormone-like effects on our body. So for you to understand that idea, you need to know what a hormone is. And in the basic principle, it's a small molecule made by your body, and it's to be used as a messenger to convey to the other parts of the body, to other cells, some certain information. And they use this chemical to send out that information. So it's the amount of that hormone that's in your body that tells your body to do certain things. So let's say you have a young child, and it's before puberty. As they get closer to puberty, estrogen levels rise in the body, and it changes the body's response. The certain tissue knows it needs to grow and turn this girl into a woman. So that's how the hormones are doing their job. They're just giving a message. But it turns out estrogen has, there are many chemicals in our environment that can have hormone-like effects, that they will trigger or simulate estrogen-like effects. So if we consume those inadvertently, being exposed to them, it would be sort of similar to taking the birth control pill. And if let's say, a man is getting that, you're going to be more sensitive to that sometimes than a woman, because the ratio of estrogen to testosterone is what matters. That's what makes us a man or a woman, is that ratio. And so you upset that ratio in either sex. But so if a man gets too much of the estrogen, like hormones, then you start, well, if you look at the older men who have cirrhosis, they start growing boobs because of extra estrogen in their body. The liver normally is supposed to break down the estrogen, and when it's dying from cirrhosis, it doesn't do that. Fat cells in our body naturally make estrogen.
Does it affect the mentally, like, is homosexuality is so prominent now, maybe is that affecting that?
I haven't seen any good research linking that.
Makes sense to me.
So that's kind of the background to what is a hormone and why do such small amounts matter. It's because hormones are made in such very small amounts on the microgram level, the nanogram level. So you don't have to consume them in very much, in big quantities. For instance, frogs can absorb enough of these through their skin, so that if they're in a swamp where there was some industrial waste that leached into the water supply, they can absorb these chemicals, and they have reaction to it just like people do. It changes their sexual organs.
Is it more catalyst, or does it actually get used up, the hormones?
Hormones do get degraded, but they can live a long time in our environment. Some of these like chemicals like alkyl phenol, they don't break down quickly. If they broke down on the order of days to weeks, they would never be of concern, because they wouldn't build up in the food chain, they wouldn't build up in our environment to the point where we are concerned about them. So these are more of the stable chemicals that they're not the natural hormones, but they have hormone-like effects, and they last a long time in our environment, and that's why they're of concern. So we call them xenoestrogens because they have estrogen mimicking features, but they're not the estrogen that our body makes. Okay, so in this, you can see how all these different secretions or cells So they measure adipose tissue, not muscle tissue, because this is a hormone alpha-phenol that gets stored in the fat. So you're not going to measure it appreciably in the muscle. So that's why they mention how much it collects in the fat. You notice here it mentions 57 nanograms per gram of fat compared to like in the urine 0.01. So it's most of the highest number is in our adipose tissue. And so if you were to now eating animal products, it's going to be contaminated just like we are. It's going to be in the adipose tissue of this animal. So that's one way to get this in our diet, is by eating the fat that's in the meat, if the animal has been exposed to these alpha-phenols. All right, let's continue.
How do people get exposed? Through contaminated food. It all goes back to a famous study about the reduction of penis size and testosterone levels in alligators living in a contaminated environment. I don't know what you all do for a day job, but these researchers observed that a population of juvenile alligators living in one lake in Florida exhibited a significantly smaller penis size and lower blood concentrations of testosterone compared to animals on some different lake. The most important difference between the two lakes was that Lake Stubby was fed by relatively polluted waters. They attributed the short penis phenomenon to estrogen-mimicking xenoestrogenic environmental metabolites of DDT that still pollute the earth. This seminal work introduced the concept that endocrine disruptors, environmental xenoestrogens, might result in feminization of exposed male animals. And that's just the shriveled tip of the iceberg. Since then, endocrine disrupting chemicals have been implicated in the dramatic rise over the last 50 years of diseases like breast cancer, prostate cancer, testicular cancer, diabetes, obesity, decreased fertility, such as dropping normal sperm counts, not to mention genital.
So the last thing he mentioned is concern to many couples, is infertility. And so if the men are being exposed to more estrogen in their environment, or xenoestrogens in this case, that will affect their sperm count, or because the feminization effect turns a man more toward like a woman. And so you're not going to be as successful making healthy sperm if you're being exposed to all these xenoestrogens. So in a woman, it raises the stimulation of the cells. Like, not all cells in a woman are as sensitive to estrogen. The breast cell is one that's very sensitive. It has a lot of hormone receptors for that. And so it tells the breast cell to grow. Now, if it happens to be a breast cell that's now become cancerous, the estrogen is telling that cancer cell to grow. And so even if the woman has gone through menopause and is no longer getting estrogen from her ovaries because they decline after menopause, these xenoestrogens can still stimulate the breast tissue even if you're not taking any estrogen or making any estrogen in your body. So that's where he's talking about the increased risk for breast cancer just by being exposed to these xenoestrogens in our environment. So it has many effects, and not just allergies. Allergy is kind of what this topic is about, but it affects us in so many ways that we don't want to have any exposure to, or as little as possible. We're always going to have some, because you can't make your environment sterile and perfect. But you can reduce the high levels. Focus on the worst offenders first. And that's
why they recommend country living versus city living with all pollution.
You want to know where the pollution sources are and avoid those. And that's what I'm trying to share here, so we can eat smarter. not harder. We're seeing an increase in breast cancer gradually over the generations, and I think this can be a factor that increases that risk. The doctors will usually take a woman off estrogen. Sometimes they'll give you a hormone like tamoxifen, which is a way to block the estrogen receptor. And so that interrupts the growth factor that the breast cancer is now deprived of that growth factor because tamoxifen interrupts that cycle or that activity. But for those women who aren't on that hormone tamoxifen, they're going to be exposed without realizing it to these xenoestrogens. And we see the cancers increase in age. Usually in the 60s, 70s, and 80s is when we're catching the majority of the cancers of the breast. All right.
Nations, preterm birth, neurobehavioral disorders in children linked to thyroid disruption, and earlier breast development in young girls. Because genes do not change fast enough to explain these increases, environmental causes.
So it's not, what he just said, you may not realize. How quickly do genes change? Well, most of us believe that we have the same genes that Adam and Eve gave to us, so how can they change? Well, we've learned that there's epigenetics, which can change over your lifetime, just through your lifestyle and what you eat. But the genetics he's talking about is the DNA level. Mutations happen at a very slow level over the generations. And so he's talking about these people in Japan who over just one generation are now seeing a large increase in these allergies, in their seasonal allergies and so on. That's too short a time frame. We have to talk about tens or hundreds of generations to see these mutations in genes to explain such a difference. You don't get those kind of changes quickly in just one generation at the gene level. You could at the epigenetic level, but it would have to be a powerful change there. So what he's suggesting here is that it's not a genetic cause causing these allergies, but an environmental cause, that it's something we're eating or being exposed to.
Since our greatest exposure to the environment is through our gut, it's no surprise that our greatest exposure to these endocrine disrupting chemicals is through diet. But which foods? I'll cover that next.
That's the cliffhanger.
I like it.
It's no surprise. If you had to guess where it comes from, it would be foods that have fat in them, right? Because we know that these are fat-soluble chemicals. And, well, plants don't make a lot of fat, so it's not surprising that it's a non-plant source that's going to give us the highest level of these contaminants. So that's what we'll cover next time. Any questions?
Just the next time will be Dr. Louis, correct?
Uh-huh. Yeah, next week.
Yeah.
Dr. Louis will be presenting this class next week. And I don't think I know if me and Rob and I have to sort out who's
Okay.
doing the following week. Okay.
So do all women, when they get past menopause or menopause, should they be taking hormone, estrogen?
I would say leave it the way God created it. There are times where you have symptoms. Some take these hormones for hot flashes.
Yeah.
If you're a strict vegan, your hot flash symptoms are going to be a lot less than if you eat a lot of meat products, because you're going to have lower levels of estrogen in your bloodstream. And so because you're at a lower level, you're not noticing the symptoms as much.
So the hot flashes, other than that, what would you have?
Well, without estrogen, the skin gets thinner and drier. Some people find they have places where the skin is now irritating and dry. And so that you can use some creams in those areas that have a very low level of estrogen. So you don't have to take it by mouth and expose your entire body. You just put it where it's needed, and we're using those creams. And then the rest of your body doesn't get as much estrogen.
But that's what causes your skin to thin out too then, huh?
Yeah, that's part of it.
The other part is we're old.
The fat stores in our body are affected by our estrogen. That's why if a man takes estrogen, he'll put on fat in places where it normally wouldn't collect.
I must have a liver test.
All right, thank you all. Let's
Thank you
close with a
very
word of
much.
prayer.
Okay.
Gracious Father, it's always a privilege to realize you know us better than we do, and you know what's good for our health. Help us to understand how we can optimize our health to enjoy life to its maximum. Give us your spirit this week to guide us in this journey. We pray in Jesus' name. Amen.
Thank you so much.